Beneath the frozen ground of the northernmost region of Finland lies a discovery with the potential to change the world's future, from nuclear energy to electric cars. These minerals make it feel like a sci-fi future is just around the corner. But, as always, it's not that simple. Let's explore why. All the way up here on the map is a region called Lapland, a land with only one chair for every 2 people, so someone has to sit on someone else's lap. It's a remote snow-covered corner of Finland, where reindeer outnumber people who live there. Here, the night sky glows with the northern lights almost 200 times in a single year. Oh, and Santa Claus has a house there. In 1985, Finland declared that Santa lives in Rovaniemi, a town just south of the Arctic Circle in Lapland. They even built Santa Claus Village, where visitors can meet with them. You can cross the Arctic Circle line and see his main post office, which receives hundreds of thousands of letters from kids worldwide every year. So, it's sufficient to say that most people know about this place because of Santa's workshop, rather than scientific news. But deep below the ice in pine forests is the Sokli deposit. It's a massive mineral geological site that's been studied for decades. It's mostly known for iron and phosphate. We use iron to make, well, almost everything, while phosphate mostly ends up as fertilizer to grow our food. However, recently, surveys revealed rare earth elements, niobium, and traces of radioactive metals like thorium and uranium. The possibility of thorium is what made news outlets excited. Thorium is a naturally occurring, slightly radioactive metal. It's way more common in the Earth's crust than uranium. In fact, it's about 3 to 4 times as abundant. Scientists love it because thorium could be turned into nuclear fuel with huge numbers as the output gain. A chunk of thorium the size of a golf ball could, in theory, generate as much energy as several tons of coal. It also comes with some major perks. Thorium reactors would produce less waste, meaning that thorium is much easier to contain and safer to use. And it even has an interesting trivia. Thorium was once used in old-fashioned gas lantern mantles because it glows when heated. And that's not all. The Sokli deposit also has other rare minerals that are critical for making magnets that go into wind turbines, electric cars, and even your smartphone. With the right investment, this single deposit could help Europe build thousands of new wind turbines or power millions of electric car batteries. So, did Finland and the entire planet just hit the geological lottery? Well, yes and no. Today, nuclear plants don't run on thorium, they run on uranium, the trusty fuel that has been powering reactors for decades. The whole system, from mining to reactor design to handling the waste, is built around uranium. It already provides around 10% of the world's electricity. In fact, in some countries, like France, it's the main source. It works, it powers millions of homes, and the industry knows exactly how to handle it. Thorium does not play by the same rules. It's not fissile, which means it cannot split and release energy on its own. Which is a fancy way of saying it needs a little help to become useful. You cannot just toss it into a regular reactor and expect magic to happen. That would be like trying to charge a Tesla by pouring gasoline into the tank. To make thorium work, you'd need different types of reactors and the system that could support them. One that's expensive, experimental, and not yet ready for prime time. So yes, Sokli's thorium looks impressive. It's full of sparkle and promise. But for now, it is staying underground, waiting for future technologies and investments. But what about those other rare earth elements? Neodymium and praseodymium might be tricky to pronounce, yes they are. But they're hiding inside almost everything these days, from earbuds to the massive MRI machines in hospitals. They drive the motors in electric cars and help giant wind turbines spin. In short, they're everywhere. And then there's niobium. This metal makes steel even stronger. Add a little niobium and suddenly you've got stronger, lighter alloys used in bridges and even rockets. Today, Europe imports nearly all of it, mainly from Brazil. If Sokli were developed, Finland could give Europe a homegrown supply. However, again, it's complicated. Like I mentioned, Lapland happens to be one of the most beautiful places on the entire planet. It's one of Europe's last great wildernesses, where pine forests stretch for miles. And digging up all those materials wouldn't be without consequences. Mining at this scale could ruin the landscape, upset Santa, or endanger delicate Arctic ecosystems. After all, we're talking about radioactive elements. It's not just about nature, though. Indigenous Sami communities live in Lapland, so they have a voice in what happens. It's a tricky situation that relies on more research and tech advancements. Until then, what are some other delicate places that could hide thorium? Well, thorium is not that hard to find. It's tucked away in beach sands and mountain deposits. But the coolest place to get it would be from the Moon. Back in the 1990s, NASA's Lunar Prospector spacecraft mapped the lunar surface and spotted areas unusually rich in thorium. Now, that's an incentive for speeding up the future moon missions, especially since our satellite probably hides elements like helium-3, which are incredibly rare on our planet. Mining the moon might be a perfect solution. Big companies will certainly have way less competition. But hey, that sounds like a decent challenge for humanity, given that the moon has no atmosphere, which makes it exposed to radiation and wild temperature changes. So, we will see. Meanwhile, let's go back to Earth for another seemingly unrelated discovery. Going down to the deep ocean seabeds, scientists recently found something pretty surprising. While exploring the Pacific abyssal plains, they discovered polymetallic nodules. These are potato-sized lumps of metal that are also important for making batteries. But the cool part is that the nodules seem to be releasing oxygen into the water. Scientists call it the dark oxygen. Ooh. Normally, oxygen comes from photosynthesis, which needs sunlight to reach plants, algae, or bacteria. But down here, in total darkness, there is no sunlight. The idea is that these rocks act like tiny batteries. Their surfaces can create very small electric currents and split water into hydrogen and oxygen. Basically, these rocks might be quietly breathing oxygen all on their own. If this is true, it could change how we understand deep-sea life. Some creatures might not just rely on hydrothermal vents or food falling from above. They could be getting a secret oxygen boost from the rocks themselves. Now, research is still new, and some researchers say this oxygen could be contaminated or just too little in volume to matter. But if it's real, it means life in the abyss might have a secret oxygen supply we never even knew existed. Creepy, mysterious, and kind of amazing all at once. It also makes us wonder about life on other planets. If rocks on Earth can make oxygen in total darkness, maybe extraterrestrial oceans on moons like Europa or Enceladus can too. The universe might be full of secret oxygen factories just waiting to surprise us. Finally, aside from thorium, Finland recently made headlines with another cool geological discovery. Scientists found some zircon crystals that washed into rivers, and when they looked closer, they noticed that the chemical signatures didn't match local rocks. Instead, they traced back to Greenland. This suggests that part of Scandinavia's ancient base might actually have come from there. In simpler terms, it's possible that Scandinavia broke off from Greenland and drifted across the ocean billions of years ago. This unexpected link makes the Nordic landscape a lot older and more interesting than we previously thought. Whether the Sokli deposit could power the future with infinite energy remains to be seen. Each day seems to bring another discovery that inspires conversation and prompts us to learn something new. Who knows what new technologies or hidden resources the next decade will uncover? Now, excuse me, since I've learned his address, I have to write a letter to Santa. I'm still trying to get off of his naughty list.
You're on a yacht in the south of France and get lost at sea. Your phone has no signal, and the GPS stops working. There's no way you could swim to safety. Your chances of surviving are pretty much zero. Today's story is kinda like that, but swap the sunny vibes for the Côte d'Azur for the freezing winds of Antarctica. And instead of calm blue waters, picture a sea packed with towering ice as far as you can see. Oh, and forget about phones or GPS. Those didn't even exist back then. So yeah, getting through something like that is basically impossible. But for the crew aboard the Endurance, this wasn't just some what-if scenario. It was real life. And yet, they survived by leaving their ship behind. Fast forward more than 100 years, and scientists finally found their vessel deep in the ocean. Now, new 3D images are helping us bring one of the greatest real-life survival stories to life. Alright, from the top. Back in 1914, the Anglo-Irish explorer Ernest Shackleton pulled together 26 men for the boldest adventure of their lives, to cross Antarctica. We're talking about the toughest places on Earth, a frozen wasteland with brutal winds, long dark nights, and freezing temperatures that can drop below -76 degrees Fahrenheit. But for the crew of the Endurance, getting there just sounded like a good time. So, on August 8, 1914, they set sail on their maiden voyage. And by October of that same year, they made it to South Georgia Island. From there, they'd finally head toward their main goal, the Weddell Sea, on the coast of Antarctica. This place is known for its brutal winds, thick sea ice, and freezing waters. Yep, not exactly the coziest place to be. Only 2 days after they left South Georgia, the Endurance ran into a bunch of thick ice, and they started moving super slowly. Thick slabs of ice locked around the ship like a slow, silent trap. At first, the crew waited. Maybe the ice would break up. Maybe the ship could push through. But days passed, then weeks, then months. The ship was stuck, completely wedged into the frozen sea, unable to move. It was February. A small patch of open water suddenly appeared a little way ahead of the Endurance. There was hope, but getting there wouldn't be easy. The ship was still surrounded by solid ice, completely blocking the way. Some of it was nearly 18 feet thick. The crew worked hard all day, cutting a narrow channel through the ice. The next day, they tried again. They even used ropes to pull away huge chunks of ice, each one weighing around 20 tons. But the space they cleared was too small for the ship to build up enough speed. And to make matters worse, the ice was already starting to freeze over again. At some point, the captain decided they needed to stop. More months went by, and the ship was totally trapped. They even saw some cracks in the ice here and there, but nothing could actually help them. And then, things got worse. The pressure from the ice wasn't just holding the ship anymore, it was crushing it. You could hear the timbers groan and the hull creak. Bit by bit, the ship started to break apart. Then in October, a year later, Shackleton had made the call. Abandon ship. And he was right, because in November, the Endurance gave in to the pressure. The front masts collapsed as the bow was crushed. A few days later, the stern was lifted out of the ice, and then the whole wreck dropped into the ocean. And just like that, the Endurance was gone, buried beneath the ice. Okay, but what happened to the crew? The men grabbed whatever they could and set up camp right on the ice, stranded in a world of nothing but white in every direction. No radio, no help coming, and no way to know how long the ice would hold. For months they drifted with the frozen sea, camping on moving slabs of ice, always alert. Eventually, they climbed into small wooden lifeboats and started rowing through freezing waters, dodging towering icebergs, battling waves that soaked them to the bone. It was exhausting, freezing, terrifying, but they kept going. Finally, they landed on an isolated rocky stretch of land called Elephant Island, their first solid ground in over a year, but it was uninhabited and offered no real chance of rescue. So Shackleton picked 5 men, loaded up the strongest lifeboat, and set across 800 miles of open ocean to try and get help. The journey took over 2 weeks, and they faced everything that could drive any man to madness. Storms, freezing spray, and waves the size of small buildings. But Shackleton kept his positivity. Losing his men wasn't an option. Thanks to his amazing leadership, they managed to reach land. They landed on South Georgia Island, but on the opposite side from where they needed to be. That meant they still had to trek for 36 hours across the island to finally reach the whaling station on the other side. Thankfully, they made it. If you were in their position, you'd probably take a hot shower and curl up in a fetal position for a couple of months. But that wasn't an option for Shackleton. He didn't rest. Instead, he immediately started working on a plan to get the 22 men who were still stuck on Elephant Island. After several failed rescue attempts, the authorities finally lent Shackleton a tugboat. That's a type of boat that moves other vessels by pushing or pulling them. When they were approaching Elephant Island on August 30th, 1916, the captain saw something. A smoke signal coming from the shore. Yep, against all odds, everyone survived. As you already know, the ship didn't make it. It completely vanished until 2022, when it was finally located on the seafloor, at a depth of roughly 10,000 feet in the Weddell Sea. It made headlines around the world, and the footage of the Endurance showed that it was beautifully preserved in icy waters. Its timbers looked brand new, and its basic structure was still intact. The wreck was covered by sponges, sea anemones, sea lilies, and starfish. It was all amazingly eerie. But how's it in such good shape? Even though it looked like any other ship of its size, it wasn't. The Endurance was built to survive tough ice conditions. Every detail was planned for maximum durability. The joints and fittings were cross-braced for strength. It was made of thick oak and Norwegian fir planks and covered in greenheart, which is a really strong wood. The bow was built to face the ice directly. Each piece of timber came from a single oak tree, shaped to match the curve of the ship. That's what helped them survive in the ice for so long. At the end of 2024, specialists did the first 3D scan of the ship. They used underwater robots to map the wreck from every angle, taking thousands of photos. These were then stitched together to create a digital twin, and now you can check it out online. Forget about getting close to the wreck though. I mean, Antarctica is still one of the most remote places on Earth, so just getting there could be a huge challenge. As the world warms and the ice in the polar south continues to melt, specialists think there will be more chances to access the wreck, but they want to keep it protected. There's even been talk about how to preserve the Endurance. One idea is getting cruise ship owners to agree not to go anywhere near the wreck. So yeah, it's probably safe to say that people in general will probably never get to visit it up close. At least, not in the near future.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.